So we just learned how to write equilibrium expressions. But what do they mean when you go to calculate them? If you go to plug in numbers, those concentrations of your carbon dioxide or of your steam, and you find a number, what does that number tell you? Well, if you had a KEQ value that was much greater than 1, what that means is, if we think about, I'm going to copy this equilibrium expression here, and I'm just going to paste it here. If you have a KEQ value that's much greater than 1, what that must mean is that you have lots of products and very little reactants. So just to show this to you conceptually, I'm going to shrink down the size of that A and B, and I'm going to increase the size of our C and D. I'm going to make it much bigger. Right? Lots of C and D, just a little bit of A and B, would give you a value of bigger than 1. So it means that you have lots of products, very few reactants, and there's two different ways we could say this. We could say that the forward reaction is favored, or you might hear it called a products favored reaction. So if you think back to those beakers that we were talking about before, and you had your reactants beaker and you had your products beaker. If it's products favored, that means we have lots of products, very little reactants once that equilibrium has been established. If the KEQ is greater than 1. Well, what about the opposite case here? So here's our equilibrium expression again. If you had a KEQ value that was much less than 1, so we were looking at greater than 1, now much less than 1. If it's much less than 1, that means that this top part is really small, and that the bottom part is what's really big. We're dividing by a really large number, which would give a KEQ that would be less than 1. You're not going to get KEQs that are negative, but a fraction of some kind. And so basically, it's the opposite of what you see above. Lots of reactants, very few products, and we would say that the reverse reaction is favored, or you might hear it called a reactants favored reaction. If you think about it in terms of those beakers, reactants, and products, if it's a reactants favored reaction, lots of reactants, very little products once that reaction equilibrium has been established.